So this is lightning talk number 8. This is Samuel Viscapi from CINES. He's going to talk about using iRODS as an entry point to, I guess, pronounce VITAM for long-term data preservation. Go for it.
Okay, then this will be a very quick presentation on a very interesting proof of concept that we made a couple of months ago at CINES with one of my colleagues, Mathieu. What was this proof of concept about? Actually, we tried to plug iRODS into VITAM, VITAM being our new long-term data preservation platform at CINES. So that's a quick schema of the whole workflow. So we try to imagine one of our users who could be part of a natural history museum. That user would try to send us digitized herbarium sheets to CINES for long-term preservation. And that user would use iRODS to do the transfer. In order to be preserved inside VITAM, a file has to be converted into the proper format, and that format is called CEDA. In order to convert that file, we use a tool named Viscapi, which is part of VITAM. So when the user submits the file, it triggers a lot of rules within iRODS. So iRODS sends the file to Viscapi. Viscapi converts the file into the CEDA format and sends back some kind of zip archive to iRODS. Then iRODS sends the archive to VITAM using the VITAM API. And VITAM, when it receives the file, replies with a X request ID. Then iRODS, still using the API, try to have more information about the status of that file. Is the archiving process successful or not? And when VITAM replies that everything is correct, then the whole workflow is complete. And for those of you who are not familiar with VITAM, I put a link to an English presentation at the bottom of that slide. So that's almost the same description, but put into words. As I said, we used the Viscapi tool in order to convert the file to CEDA. This is a simple Java code, so I could compile it with Maven. And that tool is configured with the export context.config file. That's a quick export of that file. Then I used several bash scripts in order to have the job done. So that's the archive.sh script, which sends the file to the Viscapi tool. Then the vitam.sh script sends the CEDA archive to VITAM using the API. And then the get.sh script queries the API and tries to understand what's the status of the archiving process. That's my rule engine file, the first part of it, and the second one. And in the end, we could check that our proof of concept was a success because we could see that the file was successfully preserved inside VITAM. That's a short list of the microservices we used and some useful links. And I think that's it for me. Thanks for your attention.
Thank you, Samuel.
You're welcome.
These links, we can get these slides from you and we can share them and then people can have the links as well. You could also share some of these links in the Slack channel if that's helpful too.
Okay, thank you.
Thank you so much. Appreciate it. Congratulations on your new membership.
Thank you.
iRODS consortium members.
That's really appreciated. It's very nice to be here. Thank you.
Yes, welcome.